Hello everyone, how are you all doing? I hope you all are doing good. In today's video, we are going to continue another topic from chapter Work and Energy. So let us start. What do we understand by energy? So it is basically the capacity of a body to perform work is called as energy. Now the units for work and energy are the same as you have already studied in the previous video. In SI system it is joule and in CGS system it is erg. Now we already know that energy exists in various forms like mechanical energy, heat energy, light energy, solar energy. Now in this particular chapter we are going to study two forms of mechanical energy, that is potential energy and kinetic energy, and we are also going to derive the equation on how to calculate potential energy and kinetic energy for a particular object. Followed students? This is a very interesting topic. Now just think what will happen in the following cases. A fast cricket ball strikes the stumps. The striker hits a coin on the carom board. One marble strikes another in a game of marbles. What will happen? We understand that when a moving object strikes a stationary object, the stationary object moves, right? Now thus the moving object has some energy, part or all of which it shares with the stationary object, and that is why setting it in motion. Which object will be set in motion? The stationary object. See, the fast cricket ball hits the stumps, so the stumps are set in motion. Followed? So the energy which an object has because of its motion, for example the fast cricket ball will have which kind of energy? That energy is said to be kinetic energy, the energy of motion. When an object is in motion, the energy which is possessed by that object is called as kinetic energy. Followed? Now the work done by a force to displace a stationary object through a distance s is the kinetic energy which is gained by the object. Correct? So kinetic energy is equal to work done on the object, and that is why kinetic energy is given by force into displacement. Followed? So let us start with deriving the expression for kinetic energy. Now let's see that the stationary object of mass m moves because of an applied force. Now let u, small u, be its initial velocity. Initial velocity means the speed which it has that time, the velocity which it has. So u will be 0 because it was not moving. For stationary object, always initial velocity will be 0. And the force which is applied will be F. Now this generates an acceleration A in the object, and after time t, the velocity of the object becomes equal to v, because now there is a change in the velocity. Initially it was 0, now it becomes v. So v is your final velocity. Okay. The displacement during this time is s. So the work done on the object is w is equal to f into s. Followed? Initial velocity c, object of mass m, initial velocity u, applied force f, acceleration which is generated a, time t, final velocity v, and displacement is s. You should know these abbreviations. Okay. Now according to Newton's second law of motion, force is equal to mass into acceleration. Correct? Right? Now we are going to use Newton's second equation of motion. However, as initial velocity is 0, u is going to be 0. So what is the Newton's second equation? Displacement is equal to ut, that is initial velocity, into time, plus half of acceleration into time square. Followed? So putting the value, this is very simple. See, you just have to put values. Correct? S is equal to 0. Why 0? Because U is 0. So U into 2t will be 0. Plus half AT square. So S is equal to half AT square. This becomes your second equation. Followed? Now therefore, using both the equations 1 and 2, W will become, W is equal to force into displacement, correct? So now what is the value for force in first equation C? It is MA. So here we put MA. And for in second equation, just see the value of displacement, half AT square. Followed? So multiplying, you get half MAT square. That becomes your third equation. Now if you use Newton's first equation of motion, you will get V is equal to U plus AT. Okay. So V is equal to U is 0 plus AT. So therefore V is equal to AT. Now V square will be AT square. That will become your fourth equation. So W is equal to, putting in this equation, okay, using equation third and fourth, half M AT square is V. Okay, so AT square will become V square. So half MV square. So very easy. Kinetic energy gained by an object is the amount of work done on the object. So kinetic energy is equal to work done. So what is work done here? Half mv square. So kinetic energy is given by half mv square. This equation is very important. It will be asked in the exams. Please solve this properly. What we have done is, we have taken the value of force, then we have found out displacement keeping initial velocity 0. Then we have taken the equation of work done. We have put the value of force and displacement in it, right? Then we have used Newton's first equation of motion, and then finally you get, keep putting the values, you get kinetic energy is half mv square. Followed? Now let us solve an example here. A stone having a mass of 250 gram is falling from a height. So mass is 250 gram. Now that you have to convert it into kilograms. Okay. How much kinetic energy does it have at the moment when its velocity is 2 meter per second square? So mass is given and velocity is given. The final velocity is given, right? So put kinetic energy is equal to half mv square. M's value is 0.25 kg. And V is 2 meter per second. Putting all the values, what do you get is 0.5 joules, right? Because here this is meter per second, correct? So Newton meter, that will be joule. So you get 0.5 joule. Followed? Potential energy. Now the energy which is stored in an object because of its specific state or position. See, suppose if you hold a ball somewhere on the top, correct? And you throw that ball. So that ball is going down and it will hit an object. So maybe you will get hurt because of that if it hurts you. Why? Because there is energy in that object. Why there is energy? If you keep the ball down, will it hurt you? No. Only if you keep the ball up and you throw it from there, it will hurt you. Because keeping it at certain height gains energy to that particular ball. Followed? So that kind of energy which is because of its specific state, or its potential energy or its position is called as potential energy. Followed? Now how will you derive the expression for potential energy? So here it is, to carry an object of mass m, to a height h, because we are saying it has to be placed at some height above the earth's surface, a force equal to mg, that is mass into acceleration. So here acceleration will be given by gravitational pull, because gravity is pulling the object towards the earth, okay, has to be used against the direction of the gravitational force. So the amount of work which is done can be calculated by very simple equation. Work is equal to force into displacement. Force is given by mass into acceleration. Here it is mg. Okay, this mg is not milligrams. This is mass into gravitational force. Okay, into h, because that is the displacement which is done. So work given will be mgh. So the amount of potential energy stored in the object because of its displacement, that is potential energy, can be given by mass into gravitational force into height. Followed? Now let's solve an example based on that. 500 kilograms of water is stored in the overhead tank of a 10-meter high building. So h becomes 10 meter and mass becomes 500 kilogram. So what we have to calculate is potential energy which is stored in the water. Now we know that potential energy is given by m into g into h. M is already given, h is already given, and g we know that 9.8 meter per second square. Putting all the values, you will get 49,000 joules. Followed? Just multiplication, nothing else, right? Because it is kg meter per second square, so that becomes joule. Followed? Now let us see this example. This is also very important. Ajay and Atul have been asked to determine the potential energy of a ball of mass m kept on a table as shown in the figure. What answers will they get? Will they be different? What do you conclude from this? Now see, potential energy is relative. The heights of the ball with respect to Ajay and Atul are different. So the potential energy with respect to them will also be different. Okay. So because from here it is only H2 and here it is H1 full. Correct. So because the change in the position, change in the H, the potential energy will also be different. Thank you so much students for watching the video. I hope kinetic energy and potential energy, both the expressions are clear to you. Please solve it along with the examples. Okay. Thank you so much students for watching the video.